Hello friends, in continuation with my previous lecture on thermodynamic system, today we will discuss about types of system and thermodynamic equilibrium. So, after studying the thermodynamic system, we will discuss here different types of system. So there are three types of thermodynamic system. First one is called as the closed system. So when there is only energy transfer occurs across the boundaries of the system, it is known as the closed system. It doesn't have any mass transfer, only energy transfer is there. Open system is a system when energy and mass both can be transferred across the boundary of the system. So in this system both can be transferred, energy as well as mass. And third one is called as the isolated system. In this system, when neither energy nor mass transfer occurs across the boundary of the system, it is known as the isolated system. So actually these are the three types of system using thermodynamics. Now here you can see by these pictures, these three systems are shown here, and you can see here for the exchange of energy it is shown by the red color, but for the exchange of matter it is shown by the blue color. So we can see here, if we take the example of the closed system here, this is the closed system here. So it is showing that there is the exchange of the energy. Energy can be exchanged between the system and surrounding. But you can see here the blue arrow is showing that it is stopped here. So no mass transfer or no matter transfer, exchange of matter occurs here. But if we take the example of the open system, so there is the exchange of the energy, which is shown by this red color arrows, as well as the exchange of the mass by the blue color. So these two will occur, exchange of the energy as well as exchange of matter, both will occur. Then such a system is known as open system. But if we take the example of the isolated system where there is neither energy transfer nor mass transfer. So neither there is the energy transfer nor there is the energy mass transfer of the exchange of matter. Then such a system is known as the isolated system. Now here for the closed system, we can see here, suppose this is the system, and this system is having, and this is the boundary, etc. So in this case again there is the no mass flow. So we can take the one example of that. Suppose this is the cylinder, and this cylinder is containing some gas, maybe gas in it. So this is the some system, and when some heat is given or heat is added to this system, what will happen? Definitely the pressure and temperature of the system will increase, and then it will push the piston upward. So on the across the boundary of the system toward the piston side, we can obtain some amount of work. So what we are seeing here, this system is closed from all the sides. There is no mass transfer because there is no opening. But when the heat is given to the system, its internal energy will be increased, and because of that this gas will expand and will push the piston upward, producing some work here. So this system is transferring and or exchanging some energy. The heat energy is being converted or transferred into the work or the mechanical energy. So this is the one example of the closed system without any mass flow, but there is the energy flow or the energy interaction is occurring. Similarly, if we go for the open system, so open system is more common, and in the open system, energy as well as mass both can be transferred across the boundary of the system. So in this case, here we are taking the example of the gas turbine. So in this gas turbine, and you can see this is the whole picture of the gas turbine. So the high pressure gas is entering here in the turbine section. Hydrogen gas is entering in the turbine section. So when this gas will expand having the high amount of energy, and it will expand across the turbine blades, and because of that it will rotate the turbine. But at the exit side, after doing work in the turbine, the low pressure gas will leave the turbine. So what we are seeing, the energy of the gas from the inlet to the outlet is being decreased. Its energy is being converted into some mechanical work here from the output shaft of the turbine. These dashed lines are shown, and it is known as the control surface. So what is happening here? We are converting the amount of energy of the gas into the work. This is the conversion of the energy from one point to another. At the same time, there is the flow of the gas within the system. The gas, which is the high pressure gas, is entering the system, and the low pressure gas is leaving the system. So here there is the transfer of the energy as well as mass both. So such a system is known as open system. You can also take another example for the open system. Here there is some system, we can see this is the gas here, and this gas is the hot gas, and if you take the example of the IC engine. In the case of the IC engine, as you can see here, it is the actually case of the auto engine or the petrol engine, these two valves are there, and there is one spark plug. So what happens in the suction stroke, the one inlet valve will open, the air fuel mixture will enter here, and when this valve will be closed, you will give some spark, and the combustion of the air and fuel, that is the petrol, will take place. So it will produce the hot combustion gases, and because of the energy of these gases, it will push the piston, and the piston will move, and then we will obtain some work here at the crankshaft. So the energy of the fuel or the hot gases, that is the heat energy, is being converted or transformed into the mechanical work. But what is happening here? There is the entry of the air fuel mixture, that is some mass, and from the outside or this exhaust valve, the hot combustion gases after producing the work will leave this system or this cylinder portion. So we can see there is the entry of the mass as well as there is the leaving of the hot gases, exhaust of the hot gases from this system. So in this way we can see there is the transfer of the mass as well as the transfer or the interaction of the energy also. So if these two things are happening here also, so this is the example of the open system. Third, the system which is called as the isolated system. In this type of system, neither energy transfer nor mass transfer can occur in case of the isolated system. The system is isolated from the surrounding. It is not allowing any transfer of the mass or energy from it. So normally we also use a thermos flask which is used to prevent the transfer of the heat. It is a closed container, so it doesn't allow also the transfer of the mass also. So here you can see there is a double wall insulation. आप देख सकते हैं, you can see here this is the double wall insulation, and double wall insulation, and between this double wall insulation there is the air gap. Air is not conductive. It doesn't allow the heat to flow through it because it is having a very small value of conductivity. So here the transfer of the heat is zero. Also there is the transfer of the fluid or the mass is also equal to zero. There is no work done. W is also equal to zero. So because of this double insulation, there is no mass transfer as well as no energy transfer. Such a system is called as the isolated system.